process eco-innovation. Today, the topics we're going to talk about are process eco-innovation, waste sorting and waste management, energy efficiency and renewable energy generation, sustainable supply chain management, and we'll take an example of the Kering Group. So the first process, eco-innovation. Eco-innovation is any new or significantly improved product, good or service, process, organizational change or marketing solution that reduces the use of natural resources, including materials, energy, water, and land, and decreases the release of harmful substances across the whole life cycle. Eco-innovation takes the full life cycle perspective into account rather than just focusing on environmental aspects of individual life cycle stages. It does not just mean inventing new products and delivering new services, but it also encompasses reducing environmental impacts in the way products are designed, produced, used, reused, and recycled. One focus of eco-innovation is new technologies, but creating new services and introducing organizational changes are just as important. At its core, eco-innovation is about creating business models that are both competitive and respect the environment by reducing resource intensity of products and services. So there's some examples of eco-innovation process and divided into 3 types. Industry, separation processes, membrane or distillation, construction, local heat generation and cooling, earth sheltering, daylighting, organic farming, low protein food, and production. So why eco-innovation? For the economy, it's saving material and energy costs, new products and services, new markets, and new business models. For the environment, sustainable management of natural resources, tackling climate change, improving biodiversity and ecosystems. For society, enhancing quality of life, creating new and sustainable jobs. And in politics, material security and resource justice. So let's talk about waste sorting and waste management. Waste sorting is the process by which waste is separated into different elements. Waste sorting can occur manually at the household and collected through curbside collection schemes, or automatically separated in materials recovery facilities, or mechanical biological treatment systems. Waste sorting can be done in different ways, centralized, with bin collecting, with submitting recyclable materials to reception centres, and in individual collection of recyclable materials. It can also be centralised, so mechanical sorting, manual sorting, mixed sorting, and also mixed, decentralised and centralised, a mix of both. So monitoring and assessing waste. Waste minimisation is not just about reducing materials. It is an examination of energy, emissions, and effort needed to recycle or reuse waste. As raw materials costs rise and the processing of recyclables expands, segregation of waste materials with acceptable levels of contamination may become economically viable and yield valuable income. We can do this through home sorting. The easiest way to reduce the cost of waste sorting is to sort it at home and put it separately into specialised bins. Germany is one of Europe's leaders in sorting. People there don't only separate paper and glass from plastic and food, they also sort bottles and jars by colour, separate paper tissues from magazines and newspapers, and rinse cans before throwing them away. It's a lot of work to do, but the aim is to prevent as much garbage as possible. People understand that most garbage is then resorted at the plant manually. That's why they take home sorting very seriously. For reuse, another way to reduce waste is reuse. Many people in Europe use baskets for markets and cotton bags for supermarkets every time they go shopping instead of using the plastic carry bags. provided by the store. Returnable product options and refill packs are also very popular. For example, egg cartons can be reused and beverage bottles can be refilled at the shop. Offering free bags at the supermarket outlets turns into an active environmental pollutant. In Europe, by the way, it operates an extended producer responsibility, which are the main pollutants, and they pay for the collection and transportation of its large paper, plastic, glass, or metal packaging to the place of utilization and the sorting line. So the European Unions have an approach to waste management. It's based on the waste hierarchy: prevention, reuse, recycling, recovery, disposable, which includes landfilling and incineration without energy recovery, some of which I have just explained for you. So waste management in Europe. So in Europe, 16 tons of material per person per year is currently used, of which 6 tons become waste. Although the management of that waste continues to improve in the EU, the European economy currently still loses a significant amount of potential secondary raw materials such as metals, wood, glass, paper, plastics, which present waste streams. In 2010, total waste production in the EU amounted to 2.5 billion tonnes. From this total, only a limited, albeit increasing share, 36%, which is equivalent to 1.4 billion tonnes, was recycled, with the rest was landfilled or burnt, of which 600 million tonnes, 24%, could be recycled or reused. Therefore, the 35% plus 24% is 60%. Just in terms of household waste alone, each person in Europe is currently producing on average half a tonne of such waste. Only 40% of it is reused or recycled. In some countries, more than 80% household waste goes to landfill. So let's take the experience of Germany. Germany is one of Europe's leaders in waste sorting. They have separate paper and glass. They separate paper and glass from plastic and food. They sort bottles and jars by colour. They separate paper tissues from magazines and newspapers and rinse cans before throwing them away. They also have a programme called the Green Dot Programme. If you buy a product with a green dot on it, it means that the manufacturer is insisting in financing the recycling of the packaging. We can also take an example of Australia. Since 2009, it has prohibited the use of any plastic bags in supermarkets. The focus is also on prevention of waste. State and local programs aimed at measuring packages and hazardous substances, limitation in waste use as fuel, and promotion of recycling. Another country, England, store chains such as Marks and Spencer's have stopped issuing free packages. Money from the sale of a package company transfers on the creation of new urban parks and gardens. In 2004, in England, appeared biodegradable bags for bread. Terms of material expansion is 4 years, and it decomposes into carbon dioxide and water. We can speak about Ukraine, where it's hard to guess how much time it would take to teach people to sort waste and reuse things. The country desperately needs a whole system, including regulation, education, and special funds in this field. The government needs to do more than just offering free categorized garbage bins and posters. Some years ago in the Ukrainian government, they made efforts to implement the separation of household waste in the country, but they were unsuccessful. The last try took place in October 2011, when the Ministry of Regional Development, Construction and Housing introduced a resolution approving the separate collection of household waste for further processing and recycling. This resolution has already come into force, but Ukraine is still overflowing with garbage. Today, there are approximately 30 plants on the territory of Ukraine that utilize waste, but that's not enough because of the old technology they use. Incinerating of non-sorted garbage is also not a way to solve the problem. Waste must be sorted to be recycled or burned. When we talk about the circular economy, the circular economy is a generic term for an industrial economy that is producing no waste and pollution by design or intention, and in which material flows of two types: biological nutrients, designed to re-enter the biosphere safely, and technical nutrients, which are designed to circulate at high quality in the production system without entering the biosphere, as well as being restorative and regenerative by design. Turning waste into a resource is one key to a circular economy. The objectives and targets set in European legislation have been keen drivers to improve waste management, stimulate innovation in recycling, limit the use of landfilling, and create incentives to change consumer behaviour. If we remanufacture, reuse, and recycle, and if one industry's waste becomes another's raw material, we can move to a more circular economy where waste is eliminated and resources are used in an efficient and sustainable way. The EU's 7th Environment Action Programme sets the following priority objectives for waste policy in the EU: to reduce the amount of waste generated, to maximise recycling and reuse, to limit incineration to non-recyclable materials, to phase out landfilling to non-recyclable and non-recoverable waste, and to ensure full implementation of the waste policy targets in all member states. So why reduce waste in SMEs? Disposal costs, processing costs, transportation, storage costs are typically about 15% of waste management costs. The hidden waste cost could be sinking in a company's profit margins, so savings could also take the form of reduced environmental compliance cost. Reducing waste brings down regulatory compliance costs, considering that pollution and the landfill charges increase each year. Currently, landfill charges range between €10 to 80 tonnes for 80 tonnes. It saves costs of raw materials, transport, storage, management over relatively short time periods, and with generally low risk investments, creates a socially responsible image for the company. So how do we reduce waste in SMEs? Conducting audits of material use and waste streams will help your business to cut waste and inefficiencies and gain savings. Business support in this area is increasingly being promoted and co-funded by governments. Selecting materials with high recycled content can minimize your costs for waste disposal. Ensuring proper handling and storage may help you to avoid breakages and losses. Establishing supplier take-back schemes could be a way for you to resource used materials for manufacturing. So energy efficiency and renewable energy generation. The visibility and importance of energy efficiency and renewable energy policy has increased over recent years for a variety of reasons. Perhaps the most immediately obvious for many is the need to reduce greenhouse gas emissions as a response to global warming, energy security, job creation, regional autonomy. EU legislation has also contributed its fair share in catapulting renewables and energy efficiency onto the policy agendas of Europe's countries and regions. They're delivering more services for the same energy input or the same service for less energy input. This can be done in the buildings. In the building sector, the largest user of energy in Europe, the 2010 Energy Performance of Buildings Directive requires member states to apply energy performance standards for new and existing buildings, ensure certification schemes are in place for building energy performance, and make regular inspections of boilers and air conditioning systems mandatory. The long-term aim of the directive is that all new constructions are zero energy buildings by 2021, 2019 for public buildings. As part of this, member states are required to draw up national plans for increasing the number of zero energy buildings and set immediate targets. New constructions are therefore much easier to make energy efficient, with efficiency and life cycle performance taken into account of during the design and construction phase. New buildings can integrate energy efficiency measures and renewable energies concurrently. For example, planning of new constructions should respect positioning for optimal use of natural resources, with inclusion of efficiency measures. In industry, there remains a large consumer of energy. Therefore, changes must be made not only at individual factory level, but also across entire value chains. For energy costs are therefore critical. For the average manufacturing company, energy represents around 10 to 15% of its total costs. In addition, energy savings can be achieved through the reduction of material use. With rising costs of energy, ability to use resources efficiently will determine the competitiveness of companies in the global market. Although energy efficiency measures require upfront investments, once they are repaid, they lead to profits from the measures and increased competitiveness. Recommendations can be made on investments to improve efficiency. Transport is another. After buildings, transport is the second largest energy using sector, with a 32% share of final energy consumption. Energy efficiency of vehicles has improved significantly over past decades, but there is still much that can be changed. Efficiency can be partly improved by changing user behavior, but more can be achieved at manufacturing level by setting targets for fuel efficiency, as transport relies on oil and oil products for 96% of its energy needs. It is by far the most fossil fuel reliant sector. Energy efficiency involves delivering more services for the same energy input, or the same service for less energy input. Energy efficiency delivers great advantages in terms of competitiveness and economic and environmental well-being. The expected results is that it's been estimated that the full implementation of the EU Resource Efficiency Flagship Initiative and Energy Efficiency Plan could lead to savings of around €1,000 per household every year, creating up to 2 million jobs and reducing greenhouse gas emissions by 740 million tonnes. Renewable energy is referred to as any energy resource naturally generated over a short time scale that is collected from resources which are naturally replenished on a human time scale. It comes directly from the sun, such as thermal, photochemical and photoelectrical, indirectly from the sun, such as wind, which is powered by the rotation of the earth and temperature differences, hydropower, which is reliant on the water cycle and evaporation, and photosynthetic energy, which is stored in biomass, or from other natural movements and mechanisms of the environment, such as geothermal and tidal energy. Other technologies of use to the Central European area include small hydropower, wind power, solar power, and geothermal power. So small hydropower plants have been developed to respect natural water habitats and have a very limited environmental impact compared to large hydropower plants that require dam construction. While permitting can be a challenge in many countries, there is an abundance of abandoned plants across Europe that could quickly and relatively cheaply be brought back online for energy production. Small hydropower is very cost effective, as plants have a long lifespan with low cost maintenance. Wind power is the fastest growing electricity generation technology, and in locations with good conditions, it is already cost competitive. Europe is the front runner in the technology, with growth largely driven by feed-in tariffs. The intermittency of wind and grid connection issues require good planning and management. Solar energy can also be used in many different applications. The production of electricity from solar power can be achieved through the use of photovoltaics and concentrated solar power, while solar thermal collectors produce heat for both water and spatial heating. With the emergence of concentrated PV cells to increase the yield of receptors without increasing their size and surface area. Solar thermal is a technology that can be implemented throughout the continent, being both inexpensive and easy to install, mostly onto individual houses, hotels, or swimming pools. Geothermal energy can be used as an energy source for both heating and cooling, as well as for electricity production. Geothermal heating and cooling technology has developed in such a way as to be usable almost anywhere, as geothermal heat is a widely available indigenous source that is available everywhere. Systems either operate in low temperature cells at a shallow level using a heat pump, or by exploiting hot groundwater from underground, in which case aquifer resources need to be protected. Either source can be used for individual heating systems or in district heating systems. The atmospheric energy can be extracted from the air using air source heat pumps. They work in a similar way to air conditioners, but in reverse. They can be installed anywhere at low cost and do not need access to the ground, sun, water, or wind. So what are the advantages of these renewable energy sources? The renewable energies are able to provide a range of advantages for regions that invest in them, including, as their name suggests, renewable resources are infinite, and because they're derived from natural processes, wind, sun, water, they are also free. As a result, most renewable energies have low operational costs compared to fossil fuel sources. Using renewable energies improves the environment locally through cleaner air or through accompanying resource management, and reduces carbon emissions, which are responsible for climate change. Renewably generated energies do not need to be transported far to end users, reducing logistics costs and improving efficiency. Investing in renewable energies creates jobs and keeps money in the region instead of flowing to energy-producing regions elsewhere. As renewable energy technologies can be decentralized, many regions can benefit from investments and the creation of jobs that are not threatened by globalization. Moreover, renewable energies encompass a wide range of technologies that can be fitted to any regional context, with different technologies being suitable for different regional strengths and resources. The Europe 2020 strategy is the EU's growth strategy for the period 2010 to 2020, combining a series of targets and flagship initiatives that aim to encourage smart, sustainable, and inclusive growth. Measures within the strategy are holistically linked and mutually supporting with targets set by strategy. Focusing on employment rates, R&D investment, education, poverty and social inclusion, and climate change and energy sustainability. Renewable energy and energy efficiency have not received specific flagship initiatives, instead being cross-sectoral issues of concern to all initiatives. It helps reducing GHG emissions by at least 20% compared with 1990 levels, increasing the share of renewable energy in final energy consumption to 20%, moving towards a 20% increase in energy efficiency. The strategy points out that the EU is committed by taking a decision to move to a 30% reduction by 2020 compared to 1990 levels. Although the 2020 targets for energy efficiency were not binding, a host of other legislation is in place to support energy efficiency uptake. The 2012 Energy Efficiency Directive requires member states to lead the way with energy efficiency through public procurement energy utilities to encourage users to cut their consumption, and large companies to perform energy audits every 3 years. Consumer information is also to be improved with clearer metering and billing. This latter effort supports other initiatives, including the Energy Labelling and Eco-Design Directives. As the EU member states get closer to 2020, new targets and measures will be needed, considered to keep up momentum and provide long-term security for investment in renewable energies and efficient technologies, the European Commission has published a communication entitled Energy Roadmap 2050, which explores scenarios for greater reduction in energy use, further diversification of energy supply technologies, and a higher uptake of renewable energies. In the meantime, Europe 2020 targets will only be met with continued full engagement from national and regional players, including regional authorities and municipalities. So there are several main EU funding instruments that support renewable energy and energy efficiency. There's Horizon 2020, which is a new European framework programme for research and innovation for the period of 2014 to 2020. These major European funding instruments are supporting basic research, strategic and applied research, demonstration projects, and close-to-market activities such as piloting, prototyping, and testing. The third pillar of Horizon 2020, societal challenges, is particularly relevant for renewable energy and efficiency, and will support the development of new interdisciplinary and innovative solutions for secure, clean and efficient energy, smart, green and integrated transport, and climate action, resource efficiency and raw materials. There's also the Intelligent Energy Europe programme. The former Intelligent Energy Europe programme has also been integrated into Horizon 2020 societal challenges and will continue to focus on the removal of non-technical barriers by providing awareness and information, capacity building, support to energy agencies, financing instruments for renewables and energy efficiency, and first market introduction projects. There's also the European Structural and Investment Funds. This has been earmarked at significant amounts for large-scale energetic renovation of existing buildings and the development of renewable energy infrastructures such as wind parks in various eligible regions. Also, the European Social Fund, which promotes employment, social inclusion and education, which can be useful for regions wishing to fund vocational energy-themed training. There is also the Cohesion Fund, which is aimed at EU member states with a GDI per inhabitant, which is 90% or less of the EU average. The fund supports trans-European transport networks and projects which can benefit from the environment in terms of energy efficiency and renewable energy use. For the sustainable supply chain, we can take an example from the Kering Group. So the supply chain management is the process through which a company manages the sourcing and procurement of inputs, the processing and manufacture of products and services, and their delivery to the consumer. The term supply chain includes all organizations, activities, and processes associated with all stages of the business processes involved in the planning, sourcing, processing, manufacturing, and delivery of goods and services. This process begins with suppliers of raw material and inputs, proceeds to processors and manufacturers, and culminates in the delivery of completed goods and services to consumers and end users. The primary objective of the supply chain management is to meet consumer demand with more efficient use of resources, including labor, inventory, stock, and distribution capacity. So in taking the example of the Kering Group, they are a world leader in apparel and accessories. Kering develops a variety of powerful luxury and sport and lifestyle brands such as Gucci, Bottega Veneta, Saint Laurent, Alexander McQueen, Hartney, Dodo, and many more, as you can see, Puma, Vulcan, Cobra, and Electric. Kering encourages its brands to reach their potential in the most sustainable manner. They present in more than 120 countries. The group generated revenues of 10 billion in 2015 and had more than 37,000 employees at the year end. They had an environmental profit and loss account. It is an innovative form of natural capital accounting developed by Kering that measures the impact of their activities across the entire supply chain, from farms to finished products. It allows for a new way of thinking by providing them with an unprecedented level of visibility and trackability, taking into account carbon emissions, water consumption, land use, air pollution, and waste levels, assigning monetary values to their impacts. The environmental profit and loss account allows them to make better decisions. In better understanding the environmental impacts of Kering's supply chain, they can better guide investments, better manage the challenges they may face, and better the way they do business. Through this, Kering has analysed the impact on natural capital from raw materials to the delivery of products to its customers, including logistics and stores. This assessment deepens the understanding of its activities, providing visibility so as to enable the better decision making. In doing so, it increases its ability to reduce its impact and also to respond to drivers of change in the supply chain, including fluctuations in raw material quality and availability. So the achievements. In May 2016, the Kering Group publicly reported its performance vis-à-vis the sustainability targets voluntarily set in 2012 to reduce the group's negative environmental and social impact, covering areas including CO2 emissions, hazardous chemicals, and the way the company sources gold, leather, and precious skins. The report reveals a mixed picture of progress and pain points. The company has only reached 15% of its target to source 100% of its gold from verified responsible sources. For example, Yet has achieved 99% of its target to make its collections PVC free by 2016. It has reduced carbon emissions by 11%, decreased its waste output by 16%, and cut its water uses by 19%. Progress on waste includes a no-box policy, which swapped its primary shipment packaging for bags and suitcases from cartons to recyclable bags. The group has rolled out LED lights in its stores and installed energy monitoring systems at nearly 500 of its sites. It has more than quadrupled the amount of renewable energy it bought, meaning 24.5% of Kering's energy was renewable in 2015. Kering created the Kering Materials Innovation Lab with a comprehensive library of sustainable materials and a team of technical experts to highlight innovation in raw materials, fabric, processes, and manufacturing in order to make opportunities and new, greener solutions available to the brand. The company has since performed 6,000 supplier audits, which, according to the company, covers most of its direct and indirect suppliers. He launched a Clean by Design program for best practices in textile mills, focused on improving the efficiency and decrease the environmental impact of Kering's mills by reducing water and energy use, and first time the program has been implemented in the luxury sector. Kering's set target was to evaluate all key suppliers in terms of social and environmental principles at least once every 2 years. They have the chrome-free leather tanning case study. So Bottega Veneta is an Italian luxury goods house known for its leather goods. Founded in 1966, it's now part of the French multinational group Kering. Bottega Veneta is at the forefront of a pioneering method, creating luxury leather goods that are respectful of the environment. The leather is one of the biggest raw materials contributed to the greenhouse gas emissions in the Kering supply chain. The EP&L revealed, in part, this is down to conventional leather tanning methods during the process. The action was to develop innovative metal-free and chrome-free tanning methods. The results, Bottega Vineta has purchased more than 54,000 square meters of chrome-free leather to create its leather good collection, significantly reducing water and energy use in the process. I hope you have had a good study lesson, and we thank you very much for your attention. See you soon on the Efeb network.